Christopher Basler has spent over 15 years studying the Ebola virus. His team was the first ever to explain how the Ebola virus blocks the body's defenses. Though the virus has a small genomic code made up of just a handful of proteins, it can virtually take over a healthy cell with the capability of doing massive damage to the human body.
Right now we think Ebola is, very deadly. If you get it and don't have access to a very intensive modern treatment, case fatality rates are very high.
At Mount Sinai, Basler is dedicated to developing treatments that can disarm the virus.
We hope that by understanding how these proteins work, we can also come up with drugs that will counteract their activity against the body.
The Ebola virus was first discovered in 1976 with 2 outbreaks in Africa, one in Zaire, now known as the Democratic Republic of Congo, and another in Sudan. The Sudan outbreak was caused by a slightly different Ebola virus.
Somehow the virus emerged into the human population. People started to die, in both cases in relatively remote areas, but people recognized this was an unusual event, and this led to some international attention and to the original isolation of the virus.
The Ebola virus is a close cousin of the Marburg virus, first recognized 10 years earlier in 1967. The source for the Marburg virus in nature has recently been identified as bats.
There was a source of virus associated with these caves. For Ebola virus, it's a bit more circumstantial evidence, but the data suggests that bats are also involved.
Demand for Ebola treatments are on the rise, especially with Ebola outbreaks in West Africa. So far, only a few drugs have been administered to stricken patients. However, these still remain experimental.
We know that they can work in animals, so that's encouraging. Whether they're really effective in people, I think at this point it's too early to say.
Treating Ebola has been difficult, partly because large pharmaceutical companies have been reluctant to invest in a drug with a small market size. But since there are few viruses with effective treatments, Basler says more research and funding are critical.
There's always going to be the potential there for encountering new viruses emerging into the human population. So one of the needs is not just for drugs against a particular virus, but ideally, can you come up with strategies to have broadly protective antivirals that work against multiple viruses?